There's a lot of infrastructure underground, and that really presents a 3D mapping challenge, whether this is data that should be mapped and should be portrayed in 3D or in any other form of representation. I think we'll come back to that towards the end. So what you see on the screen is a picture I took earlier this week, just outside of Victoria Station. And I thought that was interesting from a variety of different perspectives. A, it's a sunny day in the summer of 2021. B, this is kind of at 10 o'clock in the morning or 9:30 in the morning, and there are obviously not too many people there. And it's really right outside of Victoria Station in the center of London. And three, there are lots of utilities and underground structures there. And obviously, with a view like this, you can't see any of them. Now, to some of our colleagues, I guess, particularly from the British Geological Survey or other organizations, other colleagues who work with geological data, soil data in particular, that is obviously not a big surprise. If you look at it more from an above ground mapping perspective, which is an area that Ordnance Survey has been very heavily involved in over the last 200 odd years, this is actually really quite unusual. And the fact that we can't see the underground means it's really quite difficult to survey it, to manage, to do anything with it. It's not impossible, but it really completely changes the dynamics. So let's have a look at how underground utility infrastructure in particularly is mapped today. And what we see here on the screen are four maps for four different networks that the respective utilities, clean water, wastewater, electricity, and gas that's how they're representing and recording their individual networks. So the data is typically held in a geographic information system of some sort, but still printing out data or making it available as PDF maps is still quite a common way of managing this information. If you look at Ordnance Survey mapping, this is Parliament Square or Westminster Station, just on the side of Parliament Square in London. I think I was actually a little bit surprised to see some underground structures on this tensile mapping there. So you see the course of the district and circle line, you see these subways here. So there's some evidence that kind of even Ordnance Survey has actually mapped underground structure in the past and to this day in our current mapping product. This is pretty much the same theme here. We have an artist's impression of what the underground might actually look like, indicating that there is a lot going on in terms of pipes and cables and utilities. And what we also see here is that there's really an interaction between the above and the below ground, in the sense that these traffic lights will naturally have a power connection and kind of control cables which will be under the street. So what this means is that there is a lot of evidence about the underground infrastructure that you can actually see and pick up above ground and actually survey, be that manhole covers, other types of covers, or these kind of street furniture items that we see here on this image. So that was just a quick introduction into the topic. I would like to go into the question whether underground infrastructure should actually be a base layer from a geographic data perspective. We talked about 3D, how you can pull together an underground infrastructure map, or how we have done this in the past for a small part of England, and then a piece towards the end about an energy systems map, which is about a whole country approach for national coverage energy data in Great Britain. So what you see here is, well, actually, that is how the street outside of my house looked about a year and a half ago. So the gas company came in and replaced the gas mains. So that's the yellow pipe here. So it's basically a replacement program that puts some yellow lining into the existing cast iron pipes. And at this stage, at this point, just in front of my house, apparently the original pipe work was broken or not fit for purpose anymore, so they actually take this out and had to replace it. And there's a very simple idea, which is basically said, well, once you've done your excavation, once the pit is open and it exposes all of the utilities, so we see electricity, two different types of telecommunication and water in here as well, wouldn't it be a good idea to then go in from a surveying perspective, survey all of the underground infrastructure before the excavation is refilled again? And I think generally that's a really good idea, but can you do this in a large area? Can you do this in an entire country and consistency over a long period of time, for example, for the duration of putting this replacement program for the gas mains in place? And I think it's probably not too difficult to see that this can be or will be a significant challenge to create data like this, but it's certainly a valid approach to creating better underground data. Another approach would be to say, well, can't we just survey all of the underground? And I've worked quite closely with our friends in Singapore, who are also looking very intensely into underground mapping. And they basically deployed survey technology, in this case, ground penetrating radar, which is the kind of kit here that you can that can be pulled by a car and then dragged along the street, and it sends radar signals underground, and the reflection you get basically a signal that you can interpret and then create underground infrastructure maps from. And from one of the papers that they published, it becomes clear that the effort of doing this is quite significant. So in order to survey 1 lane kilometer, they estimate a survey effort of actually deploying the kit of just under 2 hours with an additional 20 hours of processing time. And I think once you're done with this, you really have an image of what's underneath the street. You don't necessarily know what's in the green areas on the sides and the pavement or beyond this connecting to the buildings. So the idea of can we resurvey everything is a good starting point. It's a good question to ask, but I don't think, at least with the technologies that we currently have, it's really feasible. Techniques like ground penetrating radar and other underground detection techniques absolutely have their place, and they can be utilized very, very successfully. But at this stage, perhaps not in order to create kind of an underground map of any country or even any city or a part of a city, I think, at this point in time. So the third approach is something that I originally got involved in, I think it was in 2005 or 2006, with a project called Vista, which was about visualizing buried assets with a purpose to reduce street works. And there was quite a large consortium that came together from various parts of the utility industry, from contractors, from government agencies, and so on. And we got together and tried to see whether it would be possible to integrate existing records from the utilities and then perhaps upgrade the data whenever the pit was open to do additional surveys. And interestingly, this project actually led to an implementation, and that's the implementation in Scotland, which is called the Scottish Vault, or the Community Apparatus Vault, where since, I believe, 2008, there's been a system in place operated by the Office of the Scottish Roadworks Commissioner, in which all of the underground utilities in Scotland are mapped and can be accessed by statutory undertakers, by organizations that have a permitted right to access these data sets. So I was involved in this in 2005, 2006, then did other things for a few years, and really came back in 2017, 2018, when from an Ordnance Survey perspective, we asked the question, what we wanted to do, how we could provide value into our utilities business, given that pretty much all of the larger utilities in the country are utilizing Ordnance Survey data, or with MasterMap as an example, in their business processes, for instance, to record their network assets. And we were involved in an activity with NWG, Northumbrian Water Group, who run an annual innovation festival. And the question we had is it possible, if we do a very focused and intense innovation activity, can we create such a map within 5 days. And this was really the starting point for a string of activities that we've done since. And you see a lot of people, obviously, in these slides. So we had this tent, and we have had between 50 and 60 people in the tent, every day over the course of this week. And we had a very intense kind of workshop atmosphere in which we wanted to, we got slightly outside of our comfort zone, speak to a lot of people, and frame the problem. So what we wanted to do is to really make the case that network operators, the operators of utility networks in this country, which includes commercial companies, but also local councils, would be much, much better off sharing their data than necessarily keeping it to themselves. And we had 3 work streams, one on demonstrating the technical feasibility, one on overcoming the data sharing barriers, which is largely looking at it from a legal perspective, as well as then the business case creation to make that case that there is economic benefit in sharing underground data. At the very start, we actually did a sense check, and we had the colleague from Northumberland Water who actually excavated and exposed the utility asset. And that was really useful, really, at the start of the week to figure out what information is required for somebody excavating underground utility asset. What do they need to know? What are they interested in when it comes to the information that could be on the map? And the use case that came out of the business case development was that pretty much all of the utilities said that the kind of lowest hanging fruit, or the biggest economic benefit that they would see, would really around health and safety of their workers, together with improvements in the business processes around this. So at this point in time, you saw these individual maps on one of the earlier slides. So it's not that there's no information available. It's just a little bit difficult to access, and you have different maps rather than one integrated information resource. And this is a fairly old, kind of very simple architecture slide, which basically says that what we wanted to do was to take all kinds of relevant data, so the repositories of the asset records from the variety of different utilities provider, maybe photos, information about soil and geology, some OS reference data, perhaps dynamic data sets such as weather data, put them all into a data environment, and then create a fairly simple data portal on it that can be utilized to view the data, as well as enabling GIS access to it. And the outcome after these 5 days looked a little bit like this. So it's turned into a group or consortium called the Northeast Underground Infrastructure Hub. And we had a technical implementation that overlaid these different underground utilities and made that visible together with information, with property information, because what the field engineers basically wanted to know is if there's anything underneath, if yes, what is it, and how dangerous is it? We then graduated this in a pilot project that was sponsored and financed by the UK Geospatial Commission, something called Newar, the National Underground Asset Hub Asset Register pilot project, in which we worked with the group of utilities and local authorities, asset owners in the Northeast, as well as the group in London, to integrate the data for a much bigger area. So we covered the whole of Northwest and a certain number of London boroughs. And with that, we really tried to create a user experience where it was very easy and straightforward for somebody working for a utility or a contractor in the office, or also in the field on a mobile device, to interrogate the data and put the information that they needed at their fingertips. And that was the point where our cartographic design team, Paul Naylor, Charlie Glynn, and others, came in and advised us on how we should actually portray the information. So what you see on this image is that the utility situation, this particular intersection, which is not uncommon if you kind of look at it across the country, is actually quite dense. So you have a lot of different utilities here, and then even for one single utility type, so red, for instance, is electricity, you have actual cable bundles and a lot of information that needs to be recorded. And working with our cartographic design team, we basically created a color scheme for the variety of different utilities based on the palettes they used, and they were quite keen to make this work from a color vision deficiency perspective, so that if you had a color vision deficiency, it was fairly easy to see the data. We had a look at what we could do in order to prevent glare. So we experimented with a variety of different map backgrounds, where we had kind of a dark scheme, for instance. And this is a slide that I actually got from Paul Naylor in terms of the color vision deficiency, which for both green and red and blue and yellow, which I understand to be two of the predominant types of color vision deficiency, where on the left-hand side you see how a particular map image would look to somebody with these deficiencies, and then the improved styling, which would bring a lot of the geographic features on this map out a lot more clearly. And this is a animation between the different views, so you can see the normal styling, which we see on the screen now, and then the stylings that would account for color vision deficiency. So we put quite a bit of thought into the visual presentation of the data, and we tried to come up with a fairly uncluttered user interface that really focused on the information that people needed to do in order to do their job. Now, what about 3D? So this is an image from one of the technology suppliers, where I think the idea has been around for quite some time, to be able to have this radar view with an augmented reality device that you can basically superimpose the underground utility data onto this image and see what's underneath. We played around with this technology, but we currently think it's not in a position that we can really scale it up to kind of a countrywide level. Another piece of work we did in the early, around about 2012 or 2013, is some consultancy work in Bahrain, where we did data integration, both the above ground data as well as underground utility networks, and that produced quite nice visualizations. There's a video on YouTube that you can also find in your own time if you want to have a look at. And this is based on an information model that's been issued by the Open Geospatial Consortium called CityGML, which is an integration model for all sorts of urban data. And it allows you to represent tunnel infrastructures in a variety of levels of detail. So you see blocky structures in the upper left-hand corners down to very detailed interior models. And there's an extension for this for utility networks. And that goes into the detail that, for instance, you can have cables, let's say telecommunications cables, which could sit in a productive pipe, and then there's some ducting around it, or multi-utility tunnels in which a variety of utilities are being fed through. So the kind of upshot of this is that in the work we've done to date, is that we actually figured, or we found that the data that is available from the network asset owners is not really 3D. So we have some depth information, particularly with sewer data or sewer networks, which are gravity fed. So the depth is quite important, but 3D information as far as the depth of features underneath the street or pavement goes is virtually not existent. So can such system actually be scaled to a national level? That is a project that we've been working on together with the Energy Networks Association since the beginning of this year. And the ENA is the umbrella organization of all of the electricity and gas network operators in this country as well as in Ireland. And we have been working with them to integrate data across the country. So this is a user interface that you're seeing here, you're actually getting quite an exclusive preview. So I don't think anybody outside of the immediate working group has seen this. So this clearly has national coverage, and you can pretty much go into the system in any part of the country and surface and query the electricity and gas network infrastructure. And this is something that's really directly supporting government policy from an energy digitization perspective, where there's a simple idea that with the net zero goals that we have and that are enshrined in legislation in this country, in the UK, we really need to have a lot of innovation to make this happen. And in order to make this innovation happen, the first thing we need to do is to surface data about the energy networks and the future demands. And that's the policy objective that this National Energy Systems Map is answering. Here's a visualization where the networks, which are both above ground and underground, are superimposed to on a flat map. So you can use this in order to come up with a risk assessment in terms of flooding. Yeah, I'm coming to an end. I think this is pretty much the last slide. This National Energy Systems Map will be launched at the ENA Innovation Conference between 12th and 15th of October. You find the URL down there. But the point I would like to make is that the cartography, the graphical representation, the visualization that you've seen, this is really the fun part that kind of comes towards the end of the chain, if you like. And before we were able to do this really nice visualizations that the users really like, particularly the guys in the field, we had to do a lot of discussions with the utilities, so a lot of engagement, a lot of legal discussions, and we had to look at the data very, very closely and come up with integration data models and data pipelines in order to bring the data together. So underground is definitely a 3D challenge. Kind of our answer for the moment, I think, is that we're really sticking with two-dimensional representations in order to bring out value of the data for utilities, for innovators in the energy industry, and I think I'll leave it at that. Thank you very much.
Thanks, Carsten. We just have one question and pretty much enough time just to answer that one. Is there any aspect of 3D to this data, or is it just a 2D overlay of data of dubious accuracy? From John Levers.
Yeah, I think the terminology dubious accuracy, I think, is quite interesting in the question. I think you can find data with dubious accuracies or positional accuracies. In some areas of the country, it's better than it is in others. I think what we've seen on the visualization I had from Bahrain, I think that should make it clear that there are some distinct 3D characteristics. There's typically kind of a stacking of underground utilities, in particular where telco appears to be the shallowest, and quite often wastewater is the deepest. But then in very dense and kind of places that have been historically populated, where underground structures have been built a lot, City of London as an example. This is, I think, where the 3D nature of the data really comes out, particularly when there's then an intersection with transport infrastructure such as the tube networks or pedestrian tunnels or other types of connecting underground infrastructure.